If this is your first time here, make sure you hit that subscribe button, turn on your notification, and give us the thumbs up.
In this video, we are going to discover the process SOV or the object to control the solenoid valve. So now that our program is open, we can see here we have one program and a few sections. Each is dedicated to a specific object. So in our example here, or for the purpose of this video, we are going to be basically looking at these two sections to interact with our block. So the first one is for the shutdowns, and this is basically what we call the process interlock, and it's going to have a video dedicated for this block to basically make you familiar with it. So for now, we're just going to mention basically that we have it here. And this is the one basically that manages all the shutdowns or the interlocks for this basically solenoid valve EY1260 as we see. And this next section we have the control. So this is the block that we are going to be talking about today, or in this video, I should say. So as you see here, the block is ready to be downloaded in the PLC. So we're going to go ahead and do that first, and then look at the HMI as well, and download the program in there, and then interact with the block from the HMI first, and then we'll come back to the PLC. So similar to the PLC, in the HMI, we can see also we have basically dedicated templates for each of the objects. So if we go to the main window, we'll see this is our valve, the EY1260. It's all ready to go. So I'm going to go online and download this as well. So now that we have our programs downloaded, we can interact with our object here, this valve, and see how it all works. So as we open it up, we can see we have three tabs in here, one for control, one for shutdowns or interlocks, and one for setup. So for the control, we have basically close, we can also put it in manual or in auto mode if we would like the PLC to control this valve, for example. So if we look at the setup first, so we have here the configuration. It's already there for the description and the tag, and for this sim timer, you can use it when you don't have real basically signal coming from the switches to tell you that the valve is fully open or fully closed. So you can use, give it, like here I'm giving it 5 seconds each, so you can use that, or you can just leave it to 0. Also, you can set up the valve type. By default, it's valve close, as well as you can set up the debounce time for the filter open alarm and filter close alarm. Right now, it's to 30 seconds. And now, if the interlocks, I can see here that I have one shutdown in here, which is the level switch high to 1260. And also I can see that because this is white, that means I can bypass it. So let's first interact with the valve and see how it works. So I'm opening it right now. I can see that it's simulating as it's opening, and it's now it's open. It's forming lights. If I close, it's going to do the same thing, and it's going to go gray meaning it's fully closed. One thing I would like to mention in here, that even if we go and let's say select that it's a fill open valve, from the color standpoint, white always means it's open, and gray it always means closed. So that's make it easier for the operators to interact with the system, so there's no confusion, regardless of whether the valve it's full open or it's failed close. And also with this little blue dot, it also tells the operator that this valve is actually a fill open valve, even without opening the faceplate and looking at the setup tab. Just from here you can tell that this is a fill open valve. So let's put this back to fill close, and let's now have a look at how the shutdowns works. So because we have these shutdowns here, that means there is in the PLC we're going to have a block for the control, which is the process SOV, as well as if we look at this section, we're going to find also a shutdown block or process interlock. And I can see here is the shutdown right there, the level switch high goes in low. It's going to kill basically this interlock, which will shut down the valve. So if we look here, we have in the control, the input 1, it's associated with the output of the interlock right there. So we can see that in there, and that's the input we put basically the output that's coming from this block right there. We also have the inputs for if you have real signals coming from the ZS on the ZSE to tell you the valve is full or closed. You can link them in there if you have. So let's basically simulate an alarm and see if this. I'm going to open first this valve and see if it's going to shut down and see what would happen. So it's opening for 5 seconds. I'm just going to give it in the screen so you can see the video. So if I go and fake signal for the alarm, I can see now right away that I have a problem in the interlocks. And also it turns yellow. That means that this is the first out shutdown or interlock that happened or that shut you down. So if you have multiple ones in here, this one will turn yellow if it's the first one. So that's a nice feature that helps operators and maintenance personnel to basically troubleshoot the cause of the problem. If I go here, I can see I can't control the valve anymore. It's the manual. And even just by looking at the object, I can tell that there's a problem. It went red. If I open it up, it tells me that there's a problem in the interlocks right there. I can open the tab and it tells me exactly what's causing the problem. So if we're troubleshooting and we want to basically run this valve, even though we have the alarm, we have the shutdown, we can do so by just basically bypassing this. If I click on this, I bypass that shutdown. And of course, it depends, or it's up to the designer to allow this to be bypassed or not, whether based on security or from the PLC. And we can see the symbol here has changed. And now I have these available to me to open the valve again. So I can see that the valve is opening and the valve now is open, but I have this warning triangle that tells me that there's something going on. So if you open it up, you can see, oh, I have an interlock that I bypassed, and it tells you exactly the one that you bypassed. It shows here now. That's still not met, but it's gray. So that's how you can basically bypass shutdown. It happens. And once we get to the section where we're going to see how to add a valve and what it takes to add a valve to your system, we're going to learn a couple other features. So that's about basically what it takes to to interact with the valve and open it, close it. To auto mode, this becomes unavailable, and now the PLC can take over and control the valve from the program open and program close commands that are available in the parameters. There we go. So we can see here is the program command open and close that you can use in your logic here, so the PLC can basically control this object. So we are somehow familiar with how to operate the valve and the functionality, and how to basically bypass, shut down, tap in, and how that's built in the PLC. Let's see what does it take to add a valve and have it up and running to our system. So if I go back to my program in here, I can go to the SLV shutdowns, and I can, so let's say this valve also has shutdowns. So I can simply just copy this one, and I'm going to call this valve UI 1270, for example. And we're just going to use the same shutdown here. It's just for the purpose of our demonstration. So all we have to do here is basically change this. And I'm going to go here to the variables and make my variable global. There we go. So that's about it. And of course, if you have multiple shutdowns, you can just add them here to the input of your interlock. Like we mentioned, there's up to 32 shutdowns that each block can handle for the process interlock. Same way, I'm just going to copy and paste basically this block to create a second one, and in here I'm going to change this to 70 basically. So that's and I'll change this to So now that we have our block basically linked to the parameters, similar to the one we have here, everything looks good. The shutdown also looks fine. So that's about what we have to do in the PLC at this point. Next, we'll go to the HMI. So the first thing we need to do in the HMI is we need to basically map our variables that we created in the PLC. And I can see them here, two of them for the control and shutdown. So I'm going to select all of them and right click and say create. And then I'm going to just go PLC. And of course, if you have lots of variables and all that, you can massage that stuff in Excel and have it here. So now that our variables are created, I can go to the HMI the main screen and simply just press Control and drag a copy of this valve in here, double click on it, and then basically fill in the parameters. So here's our 1270, same way here for our shutdown variable, and we need to basically create a faceplate dedicated to this valve. So to do so, I will simply copy this one, this template one, and just paste it here. And then we're going to rename this faceplate and call it EY1270. I'm just copying this name as I need it, and we'll simply paste it in faceplate name. So that's about what we need to do for the object. And then for the faceplate, we'll open up that, and then we'll do the same process. So 70, same here, and we put our faceplate name that we used. So that's it. So that's about the settings you need to do in the HMI. So right now everything is ready to go. So we'll go online and basically download the program. HMI, I can see my valve in here, and it's telling me I have failed, and we're going to explain in a little bit why is that. First, let's put some settings here. So now that we have the setting all filled in, we can see that it's a fill open valve. So for example, this is a go down valve, so it's will be a fill open valve. Again, we have 30 seconds for alarms. However, if we go back here, we see this is fail. In the interlock, we don't see anything in here yet. Although we do have a shutdown with it, and as we put in the logic, and this is associated, everything is in there. And we can see here that the status ready tells me it's false. So that's means the valve is not ready. So configuration is not complete yet. I'll show you why. So in the interlock in here, we will have to basically make our config or key state for our shutdown 1, because by default it's 0. So as soon as we take that as 1, we can see that the valve is come back to normal state. However, we still don't see anything here. And that's because we didn't tell the HMI that there is actually a block associated with this one. And to do that, we have to go to our block for the valve, 1270, and simply turn on this rant as interlock. So as soon as we do that, we're going to notice that we have now shutdowns, although there's still empty messages here. So we have to go back to our interlock block in here, and then we see here a parameter for the messages. And then we can write here whatever we want. So I'm just going to put this change to 1260. And we can see automatically that's appearing here. Now notice this is gray. If you want to make this a shutdown when it happened bypassable, then you will have to come to this parameter and turn this on. And now it's become white, and that means it's bypassable. So those are the settings, basic settings you need to do for the valve to become operational. And we picked, the OK state to be 1 to make the system, feel safe, rather than the OK state is 0, as you can see here. So right now we don't have any alarm, so that's good. That's 1. If we have an alarm, what we can do is this signal, which will make this off, which will shut down our valve. So this is a good approach. That's why if fuse blow or some other things happen, you will know about it. Rather, if you go the other way around, like putting 0 as your OK state. So now, again, in the same way, I can basically interact with my valve, like we saw in the beginning of this video. I can see it's open, or basically close it, I can see it's closing, etc. And of course, if I basically trigger the alarm, let's see, on, I can see immediately it says, fail, and there's something wrong. And if I open top, there's a lot of multi-nats in the same way like we just demonstrate in the beginning of the video. And you can, of course, bypass it and open or close your valves. So, like we saw here, take very little time to basically add a valve and have it up and running. By setting a couple of parameters, basically like the valve, and you're up and running. So that's basically, the good thing about using, for example, a library like this from a development standpoint, and from also interaction standpoint, from maintenance standpoint. As we see here, we can easily see what's shut down this piece of equipment and why, and also we have the ability to bypass the charging system as required to do all that stuff. So hopefully you enjoyed this video. Thank you very much for watching, and I will see you in the next video.
If you made it this far, make sure you hit that subscribe button, turn on your notification, and give us the thumbs up. And again, thank you for watching.